On this grid, draw a different shape which has the same area as shape A. So remember, the area of a shape is how much space it takes up or how much stuff there is in it. So we can see that the area is 6 triangles because we have 6 triangles within the boundaries of the shape. So if we're going to draw a different shape which has the same area, we need to use 6 triangles. Now we could draw any shape as long as we have 6 triangles on the inside. So here I've drawn a parallelogram, but there are many different shapes that you could draw. As long as you have 6 triangles within your shape, you have the same area as shape A. So lots of possible solutions for this question. Now don't confuse area with perimeter. Remember, the perimeter is the distance around the outside of the shape, but the area is how much stuff there is inside it. Complete the diagram below to make a shape that is symmetrical about the mirror line. So remember, symmetrical means the shape is reflected so that we have the same on both sides. And the way to do this is to dot our corners. So these corners here are on the mirror line, so when we reflect the shape, these will be the corners of the reflected shape as well. This point is 3 squares above the mirror line, so to reflect it, we need from the mirror line to go down 3 squares. And this point here, from the mirror line, we go up 3 squares, so to reflect it, we go down 3 squares. So now that we've dotted our corners, all we need to do is join them up, and we have completed the diagram to make it symmetrical. Here is the calendar for August 1998. Simon's birthday is on August the 20th. In 1998, he had a party on the Sunday after his birthday. What was the date of his party? So let's find August the 20th. That's when Simon's birthday was. But his party wasn't until the Sunday after. Now we can see, if we look up, that his birthday was on a Thursday, but then we would have had Friday, Saturday, and then the Sunday afterwards, so Sunday the 23rd was when he would have had his party. So the date of his party was the 23rd of August, or August the 23rd. Now, Tina's birthday is on September the 9th. On what day of the week was her birthday in 1998? Now, September isn't on the calendar, but we know that September is the month after August. So the 1st of September would have been on a Tuesday, but we want to know the date of September the 9th. Now, either we could keep on numbering each individual day until we get to 9, or we could spot that if we add 7, then the 8th will be on a Tuesday as well, because there are 7 days in a week, so we can add 7, and then the 9th of September will be the next day. And if we go up, we can see that that's a Wednesday. This graph shows the distance Alfie and Chen walked in an afternoon. They started at 1:45 p.m. and had 2 breaks. How many kilometres did they walk between the first and second breaks? So we can see on the line graph where they had their breaks, because if they're having a break, then they're not covering any more distance, so the line will be flat or horizontal. So they had their first break here when they'd walked 6 kilometres, and then they had their second break here when they'd covered 10 kilometres altogether. Now we want to know how many kilometres they walked between, so the space between 6 and 10. So we need to find the difference, and 10 minus 6 is 4, so they walked 4 kilometres, because on their first break they were on 6, and then they walked another 4 kilometres, so that they were on 10 kilometres by their second break. Now, at what time did Alfie and Chen start their second break? So the start of the second break will be the start of the second horizontal line. So that's here. Now we have time on the bottom. So if we draw a straight line down, we can see that it's after 4 o'clock, and we need to read the scale really carefully here. To get from 1 hour to the next, we have 1, 2, 3, 4 lines, and because that's the first line after 4, we have 1/4 past 4, or 1/4 past 4, which we write as 4:15, because remember, there's 60 minutes in an hour, and 1/4 of 60 is 15. So they started their second break at 4:15 p.m. We have Big Wheel, £2.50 each ride, and Roller Coaster, £1.50 each ride. Liam spends £14 altogether on the Big Wheel and the roller coaster. He goes on the Big Wheel twice. How many times does he go on the roller coaster? So if he went on the Big Wheel twice, he must have spent £5 on the Big Wheel, because £2.50 times 2, or £2.50 plus £2.50 is £5. So of the £14 he spent, £5 was spent on the Big Wheel. So if he spent £5 of that on the Big Wheel, that means he must have spent £9 on the roller coaster. But we don't want to know how much money he spent on the roller coaster. We want to know how many times he went on it. Now the roller coaster is £1.50 for one ride. That means if we times by 2, £1.50 times 2 is £3, so 2 rides make £3, and he spent £9 altogether, and if we times £3 by 3, we get £9, and 2 times 3 is 6, so that means 6 rides cost £9, and because we know he spent £9, he must have gone on the roller coaster 6 times. This shape is made out of 4 identical curves. The perimeter of the shape is 28 centimeters. So remember, the perimeter is the distance around the outside of a shape. So if 4 curves have a length of 28 centimeters, to find the length of one curve, we can divide 28 by 4. So that gives us 7 centimeters. So each of these curves must be 7 centimeters long, because 7 times 4 gives us a perimeter of 28 centimeters. Now a new shape is made out of curves of the same size. What is the perimeter of the new shape? So what we can do here is write 7 next to each curve, because we know that one curve is 7 centimeters. So here we have 6 curves of 7 centimeters, and 6 times 7 is 42, so the perimeter of this shape must be 42 centimeters. 36 and 64 are both square numbers. They have a sum of 100, because 36 plus 64 is 100. Find 2 square numbers that have a sum of 130. So remember, square numbers are what you get when you multiply a number by itself. So if we write out our square numbers, we have 1, because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. So we need to make 130 from these numbers here. So if we start with the number that's just a bit less than 130, we have 121. And to make 130, we need another 9, and that's a square number as well. So our square numbers could be 121 and 9. But there is another possible solution for this question. We could have 81 and 49, because if we add these numbers, we get 130 as well. So our answer could be 81 and 49. But if there are two possible solutions, most of the time we're better off just choosing one and writing one of those solutions as our answer. Write these numbers in order of size, starting with the smallest. So we have 1.01, 1.001, 1.101, and 0.11. And what helps us compare decimals is to write them out one below the other with the decimal points lined up, because if the decimal points are lined up, then the place values in our numbers, so our ones, tenths, hundredths and thousandths, will be lined up as well. Now when we're comparing decimals with a different number of decimal places, so this first number has 2 decimal places, 2 digits after the decimal point, but this second number has 3, what we can do is write zeros in our empty squares. And we haven't changed the number because 1.01 is the same as 1.010. All this 0 here tells us is that we don't have any extra thousandths. But once we've done that, we can compare by looking at the digits, starting with the largest place value, so starting on the left. We can see that 3 of our numbers have 1 as the ones digit, but this number here has a 0. So that means 0.11 will be our smallest number. Then our 3 remaining numbers all have 1 in the ones. If we look across to the tenths, we have 2 numbers with a 0. So let's look all the way over to our hundredths. This number has 1, but this number has 0. So that means 1.001 will be our next smallest number. Then we have 1.01 because that has a 0 in the tenths, and then this number here with a 1 in our tenths, so 1.101 will be our largest number. Now I find it easier to write the numbers out with the decimal points lined up, but what you could do is just write a 0 on the end of the numbers with 2 decimal places, so then you might be able to compare just by looking at the numbers without having to write them out. Estimate the answer to this calculation. We have 23,901 minus 5,097. Circle the correct estimate. So when we estimate, what we're doing is not finding an exact answer, but finding an answer that's close to the exact answer. And here, because our estimates are all multiples of 1,000, what we can do is round each number in the question to the nearest 1,000. So 23,901 is 24,000 to the nearest 1,000, because remember, when we're rounding to the thousands, we look at our hundreds, and because we have a 9, because we have 5 or more, we know that we're rounding up. And 5,097 to the nearest 1,000 is 5,000. Again, we look at our hundreds digit, and because that's a 0, we know that we're rounding down, so the 5 in our thousands stays the same. So 24 minus 5 is 19, so 24,000 minus 5,000 is 19,000. So that's the correct estimate. Books are 25p each at a car boot sale. Alfie wants to buy 12 books. He only has £2.35. How much more money does Alfie need? So first of all, let's find out how much 12 books cost. So we need to work out 12 times 25p. Now we could use column method for this, or if we know that one book is 25p, then 4 books, so times by 4, will be £1, because 25 times 4 is 100, and 100 pence is the same as £1. And then, if we want 12 books, 4 times 3 is 12 and 1 times 3 is 3. So 12 books will cost £3. But he only has £2.35. How much more tells us that we're finding the difference between two values, so the difference between £3 and £2.35. And when we find the difference, we need to subtract. £3 minus £2.35 is 65 pence, so that's our answer. And we probably need to use column method for this, so remember £3 can be written 3.00, so if we subtract £2.35, we can use column method, and that gives us 0.65, so that's 65 pence as our answer.